Welcome to the Math Record. Today I'll be covering the ICTM Regional 2020 Division AA Geometry, which I'll answer questions 4 and 7 in this video. And then in the next two videos, I'll answer questions 9 and 11, and then questions 13, 14, and 17. As usual, I'll take time to scroll down all 20, just in case you want to answer them yourself. Okay, so I'll give the answers at the end, and I'll begin with number 4. So in triangle ABC, the midpoint of BC is A prime, and CA is B prime, and the midpoint of AB is C prime. Okay, so let's kind of draw a general shape of how this looks. We have a triangle. Okay, and we have ABC, and then BC is A prime, which is the midpoint, and then CA is B prime, which is the midpoint, and then AB is C prime, which is the midpoint. Okay, and then there's a circle that goes to ABC, and that's O, okay? And then we have a circle that goes to A prime, B prime, C prime, which is N. And then G is the centroid of this big triangle. And determine the ratio of GO to GN. So let's first define what GO and GN is. So what's GO? Well, G is our centroid, and O is our center of our big circle of our, right? If we draw a circle, and then we draw another circle, for this one is this ABC is a bigger circle, obviously. So then it's the distance between the centroid and our big circle and the center of our big circle. So we just distance between I'll just call it B for big circle, and the centroid. And I'll just call C for centroid because I'm lazy. Okay, and then we call GN. So G is our centroid and N is our center of our small circle. So this is the distance from the small circle, which I'll call S circle for small circle, and our centroid, so plus C. Okay, so we just need to find the ratio between those distances. So what we had to do to solve this question is basically we need to connect the midpoints for here. Okay, so what that gives us? Well, basically, if you take a look at our diagram now, what do you notice about this triangle that we make? Well, if we want to prove it, well, we know that this and this are midpoints of these two sides, right? So that means this length is half of this length, and this length is half of this length. So, and we know that this is the same angle, so that basically tells us that this side length is half of this side length. Okay, so I'll just put a O and a big O to mark which sides it corresponds to. And then we just choose another triangle. So let's say this triangle and this big triangle again, right? Because we need to compare something to the big triangle. So we know that this side length is half of this. We know this side length is half of this, and this is the same angle from this triangle to this triangle, right? They're the same angle. So basically, we know that this side length corresponds with this one, and since this is the made by the midpoints, this is half of this side length. So I'll just use an X to correspond with this one. And we'll do the same thing for this triangle, but it's kind of unnecessary now because it's just the same idea again. So what I notice is that if we want to get from this side length to this side length, we got to rotate it here. That means if we rotate it here, that means this side length rotate all the way to this side length. So I'm just going to draw that triangle below so we can see what's happening. So we have something like this. Actually, I'm just going to erase those marks first. Okay. Then we have this small triangle. So it's not precisely to scale, but it's just a general idea of how I'm going to solve this. So that means our A goes all the way down to our A prime. I mean, our A prime goes down to our A, and B goes to our B prime goes to our B, and our C prime goes with C. Because remember, this side length, which is basically just this side length, corresponds with this side length. And we said that this side length corresponds with this side length, and this side length is BC right here, right? So it kind of matches around. So I'm just trying to match the smallest triangle to the bigger triangle. Okay, so the next thing we need to do is that we need to make the centroid. So we have a line from here to the midpoint, from the vertex to the midpoint, and that point of intersection is the centroid. And it doesn't matter which two vertices you do because the last one's gonna do it at the same point also. And we could call that G. So I'm just gonna draw this line for this triangle down here. So it's gonna be something like this. So what we need to notice is basically if this big triangle uses this line to cut these two in half, because that's the idea of our centroid, because it makes a median, which is cuts these two lengths in half. That means since this triangle is similar to this triangle, that means if these two are cut in half, that means these two are cut in half. And what are these side length? Well, in the smaller picture, I would just say it's these two, right? Because that's basically what this line is in here. I just cut off a big part of it. I mean, a small part right here into big here. So it's easier to visualize. And then that basically tells us that if this is the midpoint here, then the vertice to this point right here, that is also our centroid of this smaller circle. So that tells us that the centroid of our two triangles are exactly the same point. So we just need to put G right here also. So So what does that tell us? If we That basically tells us that if we make a big circle for a big triangle and we have a center at O, and that means the distance from G to O, we could call that distance D. So that's the distance for GO. Now that distance, if we had to draw a smaller circle that goes through A prime, B prime, C prime, it's just a scaled down version of our big triangle, and it's basically the same point, but now the distance is slightly scaled down. So what is that distance? Well, we know that this big triangle is made, this small triangle is made by this big triangle, but it's just cut down by a half. So if we call this a 2x scale of our big small triangle x, that means the distance here has to be half of our big triangle. So it's a half, and that's gn. So that looks like a 6. This is a g actually. So that basically tells us if we want to find the ratio GO to GN, it's just d to 1 half d, and then in integer form, just 2 to 1. And that's a way to think about question 4. So it might not seem intuitive, but it's basically how you could think about it logically. Another way is basically just using a right triangle, because this works for a general case, so you just choose a specific case and it'll be the exact same result. Okay, number 7. A, B, C, D, E, F, G, H is a regular octagon with perimeter 96, diagonal AD and EB intersect at point P. Determine the length of HP. So we have a an octagon, and let's label some points. So this is A, B, C, D, E, F, G, and H. So we need to make a diagonal from A to D, and then a diagonal from E to B. And that point of intersection is P, and we need to find the length of HP. So let's make a length from H to P. Okay, so P. So we know now first we need to find the side length. First we need to think about some angles. So we know that this angle kind of like cuts it right down here because it's a line, right, which is perpendicular because you just look at it logically. This is 90 degrees. That means this is 90 degrees because if you kind of rotate your head, it's the exact same thing. And then it's basically the same idea here. So that's 90 degrees. Now we just need to find the angle measurements of these, like right here. So we know that an octagon is 135 degrees for an interior angle. If this is 90, that means 135 minus 90 is 45. So this is 45 degrees. So if this is 45 degrees, that means this is 45 degrees because this is a right triangle. Well, triangles are 180, so it doesn't. And this is a right triangle. So this is a vertical angle, so that means this is also 45. So this is the same thing as 45, which makes sense because if you tilt your head a bit to your right, you kind of see that this triangle is the same thing as this triangle. It's the exact same thing. And now what does that basically give us? Well, we have a right triangle, and we know this side length because that's a perimeter of 96. 96 divided by 8 because of the octagon, that's a side length of 12. So this is 12. And we know this is 12. And we know this is 12. So since it's 45, 45, 90, that means this is also for 12. And this is also 45, 45, 90, so this is 12. And a 45, 45, 90, that means the hypotenuse, you just multiply by square root 2, so this is 12 square root 2. So we want to find this length, we just need to use the Pythagorean theorem, which is 12 squared plus 12 square root 2 squared, and then you take the square root. So then you can just use your calculator. So 12 squared is 144, and then 12 square root 2 squared, and that will give us 432 as our sum, and then you could just take the square root. So divide by 144, which is gives us a 3, so this is going to be 12 square root 3. And that is our answer for number 7. Okay, and as promised, here are all the answers for Geometry 2020. Well, thanks for watching, and I'll see you at the next math record.